Stream is live. Okay. Well, good afternoon, everybody. Welcome to the Chemist's Corner, where we talk about atoms, molecules, and the people who love them. And today's guest is Dr. Professor Peter Ford, Emeritus Professor at the University of California, Santa Barbara. He has a gazillion awards and a very long experience in the chemistry field, and we're very honored to have him this afternoon. Welcome, Peter.
Thank you.
So this podcast is meant for the next generation of scientists, basically to get a feel of how people particularly in our section, the local section of the American Chemical Society, how they were able to to get to the point where they are right now, what their history was, what kind of pivotal moments were in their careers, and what basically advice they can offer the next generation. So I'd like to first just have you introduce yourself, Peter, in terms of what is your present role. I think you're a professor emeritus now, but if you can just describe a little bit about kind of background, yourself, introduce yourself to, let's say, somebody, an undergraduate or graduate student who's not familiar with your work.
Well, it depends what you're asking for. If you want background, I started out getting interested in chemistry when I was in high school, but it was really more of an interest in science in general. And then I was fortunate enough to go to Caltech as a undergraduate student, which was a bit of a surprise for my high school counselors who didn't think I had much promise. And then after undergraduate school, I had seriously considered going to medical school, and I applied to both and was accepted to both. But I decided that my interest was research, and so I decided to go to graduate school instead of medical school. And then after graduate school in physical organic chemistry, actually, I went to a postdoc with Henry Taube, a very famous inorganic chemist. And after a year at Stanford, I was offered the job at UCSB and have been here ever since, actually. So, not a lot of creativity there. I just went to one place to another. So,
okay.
I'm not sure what you're looking for, Wilson, but that's
no. This is fine. This is great introduction. I think I want to kind of go back to kind of at that point where basically you were a high school student, so maybe a little bit earlier. At what point did you kind of realize that chemistry was a cool thing, and how did that happen?
Well, I'm not sure it was that I thought it was cool. But, the interesting thing about it is what got me interested in science was reading about nuclear energy. And of course, that was in the 1950s, you have to understand. So nuclear energy was both on your minds because of the potential for nuclear war, actually, because of the Cold War. And also because there was a lot of talk about how it was going to be revolutionize the energy sector and so on like that. And so I read a book by Robert Young called The Brighter Than a Thousand Suns, and I would recommend that to anybody. The book was written in the 1950s, but it was a history primarily of the Manhattan Project, although he also talks about the nuclear research that went on in Germany and the history before that. Then in that same time frame that I was reading this book and very interested in nuclear energy, a very famous chemist by the name of Linus Pauling was passing around a petition among scientists all over the world to restrict nuclear testing and atmospheric nuclear testing primarily, but nuclear testing in general. And that sort of triggered my interest in Linus Pauling, and of course he was at Caltech and research. But I'm not sure, I can't really point to anyone. See, I took a course in chemistry at high school that I enjoyed a lot. And so that maybe sort of put me on that track. And then when I started Caltech, I worked with my freshman year, I did some research with Fred Anson, who was a well-known electrochemist, and but I didn't do electrochemistry. I did something really. He introduced me to a new compound called ethylene diamine tetraacetic acid, or EDTA, and he wanted to do titrations with that. So I did some of that as in my freshman year of research. So. But that was sort of, once you're at Caltech, you're in science. There's no or engineering, one or the other, and the chemistry. Actually, I took freshman chemistry from Linus Pauling, so I had a rather interesting background there. He was very, very dynamic, but not very traditional lecturer.
Right. Then you said, I mean, you applied to medical school, and then you had the choice of going to medical school or graduate school. What was kind of the you think that led you to more in the direction of research? Was that just the?
Well, I was already doing research as an undergraduate at Caltech, and there was, like I think most juniors in college, and maybe junior science majors, reach a certain stage where they have serious doubts about what their future career is. I think there's a low point always about the third year. That's also true in graduate school. Your third year in graduate school, there's a low point. So at that point, I was sort of almost a joint chemistry biology major, and I've been taking a lot of biology courses. And so I said, well, maybe I'll think in terms of applying to medical school. And that was a very popular decision with my family, but also my brother, my older brother was in medical school at the time. So, maybe it was competition on my part. And so I applied to medical school, but as a safety school, I also applied to graduate school, but I only applied to one. Then I just decided I don't want to go to medical school because I really wanted a more research-oriented career, and so I decided to go to grad school.
Can you talk about kind of what about kind of research fascinated you? What was the love affair there?
All research fascinated me. I'm very promiscuous in terms of my scientific interests. I have a lot of different interests, and I could have gone in many different directions. I ended up I took a course my last quarter at Caltech, and this is actually kind of an interesting story. I took a course from George Hammond, who was a very well-known physical organic chemist, and I really liked his course. I really enjoyed his course, and so at that point, I still was trying to decide between medical school and graduate school. So I went to talk to George sort of toward the end of the quarter, and said to him, George, I've been accepted to medical school, but I'm also thinking about going to grad school. What do you think? And he says, go to medical school. So I, of course, take advice very well and did exactly the opposite.
So much about asking, advice from your elders, huh?
Yeah, well, that was true. So I did exactly the opposite. And I went to, he might have been having second thoughts about his career. I don't know. He ended up as chancellor at UC Santa Cruz after that. But then I went to graduate school, and I worked with a physical organic chemist who was really more physical than organic, and really enjoyed that aspect of the research, and always, kinetics and spectroscopy and various characterizations of compounds and stuff like that. That was very much it.
Yeah, can you talk a little bit about that experience in graduate school? What was that like? Was it a tortuous path? Was it all fun? I mean, just for somebody for an undergraduate who doesn't kind of know what graduate school is like, can you say a little bit about that?
When I started graduate school, I said to myself, well, I better take this very seriously. I'm not sure I took my undergraduate studies very seriously. I said, I better take this very seriously because this is a career decision. And so I enjoyed graduate school. I did not leave graduate school angry about being in graduate school or frustrated by it. Other than, as I said, there's always that low point at the end of your junior year. You're wondering if you'll finish. But other than that, I enjoyed the personal interactions. That's a very important part of science. You are interacting with other people all the time. Um, People in my research group, interactions with faculty, and so on like that. So, graduate school was very rewarding. I also, again, I had sort of broad interests, and I was working on a project of largely kinetics, looking at a oxidation of some organic compounds with serum 4 actually, and but I became interested in the chemistry of transition metals, which was not anything to be taught. And one of the reasons I got interested because I I was encouraged to attend a series of lectures by that was, I think, my second year in grad school. It was lectures by a gentleman by the name of Joseph Chatt, who was is a very famous chemist from the UK. And he was a inorganic chemist who there's awards in his name and so on like that in the UK. And he gave lectures on transition metal chemistry and studying his studies in transition metal chemistry. So that's what really triggered my interest. So I had never taken a course in inorganic chemistry. In fact, I have still never taken a course in inorganic chemistry. I've only taught them. So I had to do a lot of reading on my own. And then I had a research advisor who was very encouraging. I told him point blank that I was thinking of going into switching fields. He said, well, finish your degree first. And I said, sure, that's what I was going to do. And then I applied to, and he actually suggested Henry Talby as one possibility that he thought was one of the best chemists, inorganic chemists in the world. And so I somewhere along the line, Henry gave a talk in my graduate program, graduate school, and I then applied to him and was accepted as a postdoc there and went there. But I didn't, I think some people, I don't know what to say about whether you like. I think it's a very individual thing. When you're in graduate school, your interaction with your research advisor, that was very important. I worked with Ken Weiberg. He was a physical organic chemist, but he was always open to people coming and asking questions and talking to him. His door was always open. And he's really been my role model ever since in terms of interacting with students. Always stop and listen when they want to talk.
Mm-hmm. After graduate school, then the postdoc. Can you talk about a little bit about your postdoc experience and what that was in relation to kind of allowing you to get like a university position?
Well, that was in the days of the so-called good old boy programs, good old day, and I wasn't really aware of that. And so when I started graduate school, as postdoc, I had a 1-year fellowship, and I said, okay, I better start looking for a job right away. And I started sending letters all over the place, looking for a job. At some point, I was told, well, just wait. Professor Talby will take care of that. And I said, I didn't wait. I started applying to graduate school, to various universities, and actually got a couple of interviews from that, and mostly from my own searching. That, of course, is no longer valid. You don't. Everything has to be openly advertised, and that was not done in the 1960s. Let me tell you, it was very much of a good old boys network, and thank goodness, because we hired some awfully good people that might not have come through that program. But I didn't go through that. I basically, in fact, when I got the job at Santa Barbara, I was told that I underselling myself and I should wait till they find me a better job. And I said, I'm perfectly happy coming to Santa Barbara. So, and I did. And you know, I have no regrets for having done so. But you know, they were right in one sense that it was not an institution that one could, at that time, say was one of the top research institutions in the world. But you know that I've been on a boat on a rising tide all this time. My career has really prospered by the fact that the campus has gotten better and better every year in terms of stature and everything else. You know.
Yeah. Well, you were part of that, right?
I was here. Okay.
You're underselling yourself.
You know, I've also, let me emphasize that, you know, when I came here, there were people who had been hired at a time when, the PhD program had just started and it was only a couple of years old. And there are people here who had been hired before there was a PhD program and who did not have, you know, who didn't come with that intention that they were going to build a PhD program. But they were very helpful. People like Glenn Pritchard, who I don't know if people would know who he was anymore, but he was the director of graduate studies. But he was also very helpful in terms of, you know, I was kind of naive. I was very young when I came, and he helped me get started. There were some of my colleagues my own age, Tom Gehrig, for example. And then soon after I arrived, a chemical engineer by the name of Bob Rinker, who I had met before at Caltech, got me involved in some collaborative research with him. And so it was actually, I always thought that one of the advantages of Santa Barbara when I came here was that we didn't have a lot of resources because we were, you know, a growing campus, an emerging campus. And as a consequence, we had to work together. We had to cooperate. And that, I think, is one of the marks of the campus, at least used to be, one of the real marks of the campus, one of the strengths of it.
Mm-hmm. I do have a question about kind of going into kind of finding a job in today's world. But for at least, let's just answer Lisa's question. It says, hi, Professor Ford. Of all of you, the research that you've conducted, which project has been the most fulfilling for you, or the one that you're most proud of?
I don't know. You know, I've been at this for 57 years. In fact, I'm still at it. You know, in terms of a very interesting project. One of my students came in one day and said, I really have a hard time answering that question. But one of my students came in one day and said, I've got these. I've discovered these in the literature. I've discovered these compounds. He said, and we were looking at the effect of pressure on chemical reactions and stuff like that. He said, I've got these copper compounds that look kind of interesting because they're very luminescent. And he says, maybe we should try looking at the pressure effects on those. And so in the end run, the pressure effects weren't so interesting, but although we did do some pressure effects, but we became quite interested in trying to understand why these copper clusters were so strongly luminescent, very brightly luminescent, with very high quantities. And so we worked on this. I had three or four people that worked on this project at that time, and then we sort of dropped it, you know, more or less. We felt we had solved whatever problem we had to do. And for about another 10 or 15, 20 years, the work was not very much acknowledged, and now it's our most cited work. So,
wow, wow, that was quite a latency period, huh?
Well, you know, I think that just tells you what fundamental chemistry, basic chemistry is all about. You know, if you may well be doing something of interest in the long run, but importantly, it wasn't. We were interested in it. We were having a lot of fun studying it. And almost everything we did, we got different colors and luminescence. We changed the temperature of the reactions. And it was just a fascinating project. But at the time, it wasn't very fashionable. Now there's people using these kinds of compounds to make OLEDs and very practical applications.
Right. Okay, so going back to my question earlier, I mean, what does it take, given kind of your extensive experience in the academic world, what does it take for a graduate student nowadays to kind of uh, get a university position and succeed in the academic world?
I don't have a clue. I really don't. No, I mean,
Okay.
I think the main thing is people should be their own. They should develop their own ideas, um, and because that's very much a part of it. I think we way overstress the when we hire junior faculty now, we way overstress, how many papers they've published or something like that, as opposed to really hiring people who are really interested in what they're doing and really creative and so like that. And I think that's what our focus should be. I'm talking from the faculty standpoint, uh, in terms of hiring new faculty. Uh, I've had very successful young students. Most of our, in terms of going into academics, most of them have taken postdocs. I think I've only had one student accept the job directly for at least for a university position directly from my research group. And even in that case, I think it was a mistake. They would have been better off broadening their scope by going into doing a postdoc. I think the other thing about it is, in general, research is not something you do by yourself. You need to collaborate. You need to work with other people. I've been very fortunate in having not only really outstanding students and postdocs, but I've also been fortunate in having collaborators around the world, friends around the world who not all of them are collaborators, but people you can talk to and people you can bounce your ideas off of.
Right. And I mean, in that kind of endeavor, how much is that kind of the contributions for kind of yourself? What type of person do you need to be in order to get to that stage, or is it just all external influence? I'm just trying to get a feel for how you can
Well,
tell people about it.
well, again, if I were a student today, I would want to go to lots of conferences, but not, the American Chemical Society conferences, which I've gone to many, 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 tend to be too large. Go to something like a Gordon conference and learn to interact with senior people and find out what makes them tick, what they're interested in, and it is like I say, it's you have to be. I don't know if you have to be a people person in the sense of being a jolly fellow or jolly female fellow, well met, but it is important though to be able to interact with others and find, listen, not only have your ideas and talk, but listen to other people's ideas and be and interchange these things.
Mhm. Right. And then I mean, so you mentioned find out what makes people tick. So what makes you tick, Peter?
I don't know. I think it's curiosity.
Mhm.
We have a new project now that I'm working with two undergraduates and a couple of people from STL, which is a local laboratory, although they're both retired now. So um, we started this project actually during COVID, and what we're trying to do is trigger chemical reactions using X-rays, um, which of course people have done. But the point is that I don't know anything about radiation. And I was interested in radiation partly because of its applications in cancer treatment. And, I'm just curious. I wanted to learn something new. I think curiosity is really the trigger for me to see something new and follow through and learn something new.
And is that something that can be cultivated, or is that something you're born with?
Well, you can practice it. Um, I actually had advice when I was a grad student from another grad student saying, whenever you read a paper, you should look at it from the standpoint of what could you do differently, or what could you do to improve the study, or something like that. And so I would write for years. When I read a paper, I'd take a little index card. I don't know if students know what index cards are now, but I'd take an index card and I would write on it the title of the paper and the authors and the reference. And then I would write down my thoughts about what that, not, this is what they saw, but what could be done differently, or what could be solved. And so it was a matter, and that I think was a training process. I very rarely used any of those ideas, but I was training myself to think in terms of creativity. Okay.
Mm-hmm.
Now, there is certain some of that is natural, but a lot of it is teaching yourself to be creative and being curious. I mean, I think you have to have curiosity.
Mm-hmm. Okay. Let's see. Maria Sanchez has a question. What part of your job do you enjoy the most? I don't know. Maybe doing research, mentoring new researchers, the collaboration aspect of seeing the impact afterwards.
Well, I think the most important thing, and certainly the thing I feel the most award from, is working with students at all levels: undergraduates, graduate students, and postdocs, and also colleagues. But the idea of seeing what I call early career researchers develop, to think I had some small impact upon that. I mean, my advice always is to them: think for yourself. Don't let me think for you. And that's benefited me. I've had graduate students came up with ideas, like I talked to you about the copper work. I would never have started a project in copper without the students encouraging me to do that. And so, but that's the exciting thing, and seeing them, I stay in touch with quite a number of my former students, and I really enjoy seeing how they've developed through the years. And some of them have been much more successful than me.
Mm-hmm. Right. And it takes, I mean, so is that kind of, how would you describe the way you run your lab? Is that how I mean, compared to other people, I guess you're less of a micromanager. Is that?
I don't compare myself to others, but I have, as I said, my role model with Ken Weiberg at when my graduate studies was that I leave my door open. If I'm and people can come see me, students can come see me at any time. They usually start with, a new student with, now I don't have any PhD students anymore, but new student, for example, talk to me about possibly doing research. I propose some ideas to work on. Then, I really trust them to take a lot of the initiative and lead with that. That doesn't mean I don't consult with them all the time. I try to be there. But I don't go into the laboratory and say, why don't you do this experiment? Why don't you do that experiment? Or I just read this in the paper. Why don't you go do that? That I think is, it doesn't, you can do it once in a while, but you do not want to inhibit their creativity. And so therefore, if you're directing them away from their own ideas, I think you miss out on their development. And actually, like I say, I've benefited from it tremendously, from their individual.
And any other kind of advice you have in terms of fostering creativity in young chemists?
Think for yourself.
Okay.
Don't let other people tell you what you should think. Think for yourself. Okay. And that goes for everything. If you want a career, have an ambition to follow through on your ambitions. At least have a goal. You don't want to always reach those goals, but have a goal.
Okay, great. And I guess it's kind of the answers the kind of one of my last questions of this type of interviews. What advice would you give to the next generation? And that's great. One final question, Peter, I have to ask is, what is your favorite molecule or atom and why?
I won't say ethanol.
Okay. What is your next best favorite?
I think the most interesting molecule out there is water, H2O. I think it really is. Yeah, it's if you go look at the chemistry of water, it still has everybody. It's really something complicated. I'm not studying it, but it's an incredibly interesting water molecule.
Okay, there's much to be studied in that front. Okay, with that said, well, Peter, thank you very much for this enlightening half an hour. Really appreciate your time, and then hopefully, the next generation gets something out of it. So, have a good afternoon. Bye, everybody.
Thank you.
Take care.